you've just seen me put water in here. Shh. I've put a bit of indicator in so that we can see a colour change should it occur. I've got here 3 little brown glass jars which are mainly filled with paraffin oil. Okay, this is lithium. Okay, this is lithium. Now lithium is the first true member of group 1. Now it's kept in a brown glass jar with oil in it. Okay, and that's because it reacts very readily with oxygen in the atmosphere. Okay, now I'm going to take out a piece of lithium, and we can see that when you first take it out, okay, it's a dull grey metal. Okay, I've got a reasonably sharp scalpel, but it's not that sharp. Okay, Siobhan and Emma, and I'm going to cut through the lithium with my scalpel, and it's quite difficult, but the very fact that I can cut through a metal suggests that it's not that, it's a bit unusual. Let me just show you this piece. Right, the cut surface is a little shinier than the surface that was previously covered with oil. So when you cut through it, it is actually shiny underneath, so it is a metal. Right, in she goes. And to start with, not a lot's happening because the oil's actually keeping the water off. But you see there's 2 things happening there. There's a lot of fizzing going on, quite a lot of fumes coming off. What else is happening?
It's going pink.
The water is going pink, so it's no longer a neutral liquid. What is it now?
Alkali.
It's an alkali, good.
These are the council now.
Now, I've just filled the test tube with water, and I've just inverted it so it's full of water and standing up. Can you see the pink water in the test tube? If I bigger even than Adam,
what happens if you put it all in?
it would fizz a lot, and I would be coughing even more, and I'm tempted to cough now.
Will you die?
Oh dear. Will I die? I don't think so, Adam, no. Underneath the test tube, so in it goes. Under the test tube. Let go. There he goes. Now then, that test tube is now full of the gas that was being given off. Okay, so the gas is hydrogen.
So the lithium's taking the oxygen.
And the lithium oxide, which you've just mentioned, is actually what's making the water go pink. Scott has just pointed out that the gas here is possibly hydrogen. In fact, that's what it is. I'll show you that in a second. And Ashley just pointed out that it could have been lithium oxide, but lithium oxide is actually a solid, but it is soluble in water. So the lithium oxide is dissolved in the water and forms something slightly different. It's not lithium oxide, it's something called lithium hydroxide. Okay, so the reason that the water is going pink, the reason that the water is alkaline, is due to the presence of lithium hydroxide. Okay, now how do I prove to you that gas is hydrogen? What's the simple test for hydrogen?
Split in it.
Good, and what will happen?
It'll pop.
It should pop. Now, to say, okay, so
oh, mate, is that a windproof one, sir?
it is. Okay, so just
Oh, I've heard this before, actually.
okay, so it's a bit of a weak pop. Okay, that was lithium. Now moving down group 1, what's the next element in group 1? What's the next element in group 1? So I've just done lithium. Sodium. Okay, so perhaps not surprisingly, we got a bit of sodium here. Once again, it's kept in a brown glass jar with oil. Why is that?
Because it's dangerous.
Be more specific than that.
It
reacts with oxygen in the air, it reacts with moisture in the air. Right, so sodium. Now, what I want you to notice about sodium is a couple of things before I put it in the water. The sodium is a lighter grey colour.
Just put that in.
And when I cut it, I want you to notice that it's slightly easier than the lithium. And it is shiny once cut. Okay, so can you tell me how is that reacting compared to the lithium?
It's bouncing around.
It's what, sorry?
Bouncing off the side.
Is it reacting more or less? More. It's actually, it forms a little ball on the surface. It melts and forms a ball.
Why a ball?
Sorry?
Why a ball?
Because when it melts, the easiest, most symmetrical shape to form is a ball. Now, there's one observation that you need to be aware of for the Group 1 metals that I've not pointed out to you yet. These materials are metal, and I've put them into a water trough. What should strike you as unusual about that? What observation can you make, regardless of any chemistry? It didn't sink, excellent. They don't sink, but their density is very low. Now, the final one that I can show you, there are more obviously, is what? What's this third one? Potassium. Okay. Right, so this is the school supply of potassium, it would seem. Once again, it's very soft. In fact, it's even softer than sodium. Now, when we put sodium into water, compared to lithium into water, how did the sodium react?
Bounced around.
In comparison?
It was faster.
It was more reactive, yeah? It reacted more vigorously. So, what do you think the potassium's going to do? Compared to the sodium?
Go faster.
Faster again, okay, react even more. Okay, so let's see that that's true. Oh, steady on.
Oh, well.
Okay, so,
Told you.
not only is it...
Come on!
It gets so hot that it actually ignites its own hydrogen. That flame there was due to the hydrogen. Okay? Are you ready? This is potassium again.
Go on,
It's
lad.
gonna blow.
The Group 1 metals are kept in oil in a brown glass jar to protect them, or to prevent them rather, from reacting with moisture or oxygen in the atmosphere. When you take them out at first, they are what we call tarnished. That means they are covered in the oxide of whatever metal it is. So lithium is covered in lithium oxide, sodium is covered in sodium oxide, etc. When we cut through them, Tom, which is relatively easy considering they are metals, they become shiny. But very quickly they tarnish, they go back to being grey again because they very quickly react with the oxygen or the moisture in the air. When you put them into water, the one thing that Rebecca pointed out, they float, which in itself is unusual. The fact a metal floats on water is unusual. They react with water, which again is quite unusual, but they react quickly. Lithium slowly bumbles round the surface, giving off hydrogen. Right, good. What's the name of the alkali being?